Good afternoon, everyone. I'm Gina Bagnani with Florida DOT. Welcome. And today's presentation, or one of them, is the influence of frontage access road points relative to X-ramps versus traditional ramps and entry and exit gores with focus on safety performance. This presentation will be presented by Dr. Karen Dixon. She's a PE and a senior research engineer and program manager for the roadway safety program at the Texas A&M Transportation Institute. She earned a bachelor's degree from Texas A&M University, master and PhD from North Carolina State University. She's also a registered nurse in the state of Texas and Arizona. Karen is the chair of the TRB Highway Safety Performance Committee and a member of TRB Operational Effects of Geometric Committee. Karen is a co-author of the 2014 TRB Access Management Manual and the 2016 TRB Access Management Application Guidelines. Her research also focuses on safe transportation facilities for all users. Please welcome Dr. Karen Dixon.
Howdy. By the way, that is an official required salutation on the Texas A&M campus. So it's not just a Texas thing. We're actually expected on Texas A&M to say howdy to everybody. We also sometimes expect to hear it back. I'm just saying. Let's try that. Howdy. I'll take the O2. So we had a problem that happened in Texas. You know how it is when anytime you think you're fixing a problem, you create a new problem, or at least it seems like that might be what's happening. Well, we had this happen in Texas. A couple years ago, we started converting a lot of our roadways, our frontage roads along our freeways and divided highways that had interchange separation. And most of them had traditional diamond interchanges. And what we were finding is that we were having a lot of congestion at the interchange points. And sometimes we were having cars backing back up onto the freeway because... So we were having cars back up onto the freeway because of something that was happening on the surface street, like a signalized intersection or something. And so we took a closer look at what our options were to try and mitigate this. And the solution was to change the configuration of the ramps, and it has lots of benefits. I'm going to kind of walk us through those, but the drawback we very quickly discovered is that they were mature frontage roads, and what we ended up doing is changing mature frontage road configurations where driveways already existed. And when you go to a property owner and say, I'd like to move your driveway because I'm going to change the way my freeway works, the driveway or the property owner will typically say, well, I don't want to change the way my driveway works. And so we needed some substantive reason to justify asking for them to be moved. And so that was the inspiration for this particular project that was funded by the San Antonio District for the Texas Department of Transportation. San Antonio District is the first one to wide-scale implement this type of configuration. But I suggested to them that for their study to be credible throughout the state of Texas, it would be best to study the entire state of Texas, and they agreed. So they funded it, but it's extended to the entire state of Texas. So essentially, what we were trying to do is assess the safety on the frontage road with particular attention to the driveways. Now, at the time I asked them, do you want me to evaluate the crash condition on the freeway at the same time, because there's some logical expectations that you might just be transferring crashes from one location to the other. And they said, that'll be phase 2. And they kind of said that laughingly. And now we are working on phase 2 because they decided that was something that was worthwhile to pursue. So this is just a kind of simplified schematic of what a diamond interchange configuration might look like. And as you can see, there's off-ramps before the interchange, the structure, and on-ramps after the interchange structure. And the term diamond comes from the fact that if you kind of creatively sketched a line, what you would basically have there with your ramps is a little diamond. So here's some things about the traditional diamond interchange that we need to think about. The area between the on-ramp and the off-ramp, by its nature, creates a weave on the freeway. So weave on the freeway, where cars are coming on the freeway at the same time that they're coming off the freeway, can create additional safety issues. It certainly can contribute to congestion. So Essentially, one car will be doing this, getting on the freeway and going straight. Another car maybe is just getting off the freeway at the same location. Somewhere along the way, their paths generally have to cross. You can be creative about how you manage the lane configuration, so they have to weave in, merge in and exit back out, but nonetheless, it does create some sort of effect on the freeway lanes. So this is basically what I could call a zone of the weave merge on the freeway, basically the Gore to Gore on the freeway itself. An alternative would be the X-ramp configuration. So this is a similar simplified schematic, but here we basically just take those ramps and we shift them to the other side. So I'm sure our people who are driving on our interchanges think we're crazy because we're taking out ramps and then moving them to the other side and putting them in. But here we bring the ramp on before the bridge and then we take it off after the bridge. Now the nice thing about this is if we were having heavy congestion at, say, the signalized intersection on the surface street, it doesn't back up onto the freeway anymore like it was with the diamond interchange configuration. It also takes some of the movements from the freeway and shifts them to the frontage road, for example, weaving configuration. So as you can probably guess, this is why it's called the X configuration, just like we saw with the diamond before. You can just see if you look at the ramps and connect them, it basically makes an X. They have all sorts of other cool names for it, but we still call it the X configuration. So just as a reminder, this is kind of how this one would work. Now we're taking them off. So this is, of course, interchange to interchange. We're taking the traffic off of the freeway and then bringing it back on before the next interchange. So now what we'll have is a car that exits, wants to stay off of the freeway, and we have a car that wants to go on the freeway. Still they have a weaving point, but now it's at the lower speed frontage road location. Our problem is this is also where driveways are. So yes, we've probably done something to improve safety and operations of the freeway, though I will mention that there is an extra little side effect that has been discovered on this, and that is that if someone doesn't want to go through the signalized intersection, they can get on the freeway and get off on the next exit and bypass the signalized intersection. And that's a problem with the X-ramps too. So every time you come up with a good solution, there's always a tricky little thing that shows up, and we've been noticing that as well. So a few locations, the signalized intersections are so much better now on the surface street, even though we thought we were shifting more cars to them because they're just going back up and over to try and avoid the signalized intersection. So here the weave or merge is actually between the Gores on the frontage road instead of between the Gores that are on the interstate. And so we were curious at these locations where we have driveways, what is the implication? And is there some way we could put some constraints about where a driveway should be relocated or located if it hasn't been constructed at this point? And that was kind of the goal of trying to figure out what we're looking at. So as I mentioned, we told the San Antonio district that what we wanted to do was do it for the entire state of Texas so we could have a representation of the entire state of Texas because it has such a robust frontage road system. If you get out in West Texas, which is where actually I grew up, we have very wide open areas. It's not real congested. Maybe it's not a big issue to have X configurations. Maybe diamonds are perfectly fine. They still have a lot of clover leaves out there because they have so much space out there. If you're in like Dallas or Houston in the congested areas, you might have a very different situation. So we felt it would be good just to find something that represents the entire area. So what we did is we, of course, said, wouldn't it be nice if we actually had a database that showed every single interchange that we have in the state of Texas? This is similar to having a database that shows every intersection you have in your state. Do any of you have a database that shows every intersection in your state that you know about? Maybe one. So how about interchanges? Anybody have a database that shows every interchange? Yeah, we don't either. So we had to, of course, use some GIS manipulations to try and at least identify candidate sites, and then we spent a lot of quality graduate student time going through each site and confirming it was, in fact, a interchange and what type of interchange configuration it was. Since we've already been putting in the X configuration interchanges, and they've been doing it for some time in some locations, and some of them are more recent, we had to also confirm the date of construction for them. So it started a pretty lengthy time period. So our first goal was to find candidate sites, then do a random selection, and then go and individually inspect them. And so on our candidate sites, what we did is we basically found places where we had the lines in the GIS map crossing at least in 2 locations at an intersection to represent the frontage roads and then the freeway, and then we also used a buffer and grabbed any of those and said this is a potential interchange location, and then we excluded anything that wasn't a diamond or an X configuration. We want to do a stratified random sample so we'd have representation from all of the districts that actually have diamond interchanges, and so that was our first stage sampling. Ultimately, what we had were 93 randomly selected locations, and of those, 31 of them were traditional diamonds and 62 actually had X-ramps, which surprised us. We did not realize that the state was that far along in their conversions. Now, this is not the total number in our state. This was a randomly selected sample for statistical purposes. Because the second phase of our project is going to be to look specifically at the freeway side, we think we need to have these a little more balanced, and so we're in the process of incorporating 30 additional traditional diamonds, so we expanded that portion of our sample. Our original sample was just, we got what we got. Some of the things that we used to collect the data, we used, obviously, our student time. We identified what we were called site boundaries. One of the things that when we selected our random sites is we basically just selected a point. And so we had to figure out what does that point define? You know, is that point just going to be one interchange? Is it going to be the interchange and then the approach upstream and downstream? These are freeways, so is it frontage roads on both sides of the freeway? So that's one of the things that we had to narrow down. Rhino is the road classification or characteristic database for the state of Texas, so we combined Rhino data along with Google Earth and Street View to try and come up with as much as we can seeing in our office. And then we, of course, assembled crash data for each of the locations. So I'll go to the next one because it kind of shows the tags. So basically, if I were doing a sample, what I call the central intersection would be my point that I actually randomly sampled. And then I said, okay, so now I'm going to go upstream and I'm going to go downstream. So we had for each site, we had a central intersection, then we had a beginning intersection and an end intersection. So we basically have 4 legs because we have approaches on each. And then every once in a while, it just coincidentally happened that another random sample was one of our beginning or ending intersections. And when that happened, we extended the interchange for 2 more legs to the next intersection upstream or downstream, just so that we can make sure that we kept it scientifically unbiased. Another thing that was important to us is to try and determine exactly where the driveways and the Gore locations were. We used aerial photography for most of that. Some of the Gores were handled a little differently. In many cases, because of urban right-of-way constraints, the frontage roads were pushed right up against the highway, and then they just had retaining wall systems. And it was really hard to identify the Gores at those locations. So that's where the students spent plenty of Street View time. I myself went out and drove a few of these sites as well that we just couldn't ascertain from the sites what they were looking like. So this is just an example of some of the information that we identified. Obviously, we found out where the Gore was. We looked at the physical Gore nose. We looked at the back of the Gore. We looked at any driveway locations that were on the frontage road. Some were beyond the Gore limits, some were within the Gore limits. We tried to determine that as well, so we could determine the influence of those driveways and their proximity to the Gore. An interesting thing that we noticed is that for the most part, this isn't a surprise to us, but for the most part, for the diamond interchanges, which I'm calling traditional in this particular slide, the weaving area on the frontage road, again, we're just focused on the driveways on the frontage road. So the weaving area on the frontage road for the segment is at the beginning where that first on-ramp occurs, and then towards the end where that next off-ramp occurs. Didn't really have any influence at all in between. There's a few cars that maybe just happened to be on the frontage road cutting from one intersection to the other, but for the most part, most of the vehicles that were between these 2 influence areas were actually accessing the access points there. And if any of you have been to Texas, you'll know that we use our frontage road as essentially a really high-speed functioning one-way arterial. There's a lot of land development, and so usually those are, businesses that are pretty substantial businesses. For the X-ramp, the actual place where you have the influence on the frontage road is almost the opposite, but includes the Gores as well. And so here you can see that what you typically will have for the strongest influence for your configuration is between the Gores on the frontage road. I recognize that there are going to be some cases where, say, someone comes off of the freeway, then goes down to the next intersection, and then they turn, and so they might have extra weaving configurations with other vehicles. But for the configuration we were interested in, specifically the X configuration, the influence area is between the two. So kind of opposite to what we see in the traditional diamond. And of course, you can imagine similar configurations would be suitable for the freeway as well. So we then began to assemble our data. We looked at what ramp type it was, which would be on or off ramp by ramp type, the length of the segment, the distance between the Gore noses. We developed something called a Gore ratio because some of these facilities, the frontage road between intersections was extremely long, and in other places it was quite short. And so we thought, well, if you have a 200-foot Gore on this road, which would be extremely short Gore, and you had a 200-foot Gore on this one, which might be very typical because they are a tight urban location, should we treat those the same? And so we came up with this Gore ratio idea of having the Gore distance divided by the segment length, just so we could put it in perspective for us. And then we have the total segments, driveways, and also the Gore driveways, the ones that were actually located near or in the vicinity of the Gore. We actually measured the distance as well from the Gore, so we had excess density along the road and excess density within the Gores. So you can see I have distance from the Gore nose to the first upstream and downstream driveways for G1 and G2. G1 is just my Gore 1 abbreviation, and G2 is my Gore 2 abbreviation. And then, of course, the important characteristics of the roads, like the number of lanes and the traffic volume, were necessary as well. This is another problem we had with the CRIS. CRIS is our crash database in the state of Texas. This is a well-known deficiency for the Texas crash database, but I think it's worth noting. All of our frontage road crashes have a tab that says the frontage road crashes, but when they are mapped to GIS, they are mapped to the center line of the freeway. Isn't that swell? And so that means that you have to go through and manually determine which frontage road it applies to by basically by direction of travel and other crash characteristics, and manually assign it to one or the other of the frontage roads. And so that was a fairly time-intensive thing to try and do, but we had to do that to try and take a look at it. Another issue is we're doing a safety assessment. And if the frontage road crash happens to be near the intersection from the crossroad that goes either under or over at the interchange, there might just be intersection crashes there. They don't have anything to do with this. And so we excluded 250 feet upstream and downstream of the intersections because we assumed that those would be probably associated with queuing and other intersection activity. The 250 foot is a recommendation in the Highway Safety Manual. So we conducted a safety assessment. We merged all this data together. We looked at 3 years, 5 years, and even 7 years. The data extended back to 2015 as the most recent complete database that we had at the time of starting phase 1. And then we started trying to determine what were the critical variables for these individual configurations, the traditional diamond versus the X configuration, and what we could find out if we looked at just fatal plus injury crashes versus total crashes. So for fatal plus injury crashes for a 3-year period, we found that when we did a model, the critical variables were the Gore ratio, the number of driveways in the Gore region, that's like within 400 feet of the Gore nose, the upstream distance from the nose of the first Gore to the closest driveway was a critical element, and the prevailing number of lanes between Gore 1 and Gore 2, also a critical element. When we looked at total crashes, we had exactly the same list, except we had one more list, which was there was a downstream distance from the nose to the Gore 2 to the closest downstream driveway. So what's clear, of course, is orientation to the respective driveways is a critical factor that we need to consider, as well as the length of the Gore and how much of the facility actually is going to have this Gore space. I am not going to expect you to read my numbers here, just to show you that we did develop some regression equations using negative binomial regression logistics for the 3-year period to try and take a look at how critical those values were. And the reason we did this is because ultimately, you recall, the idea behind this study was we want to be able to document when we ask someone to relocate their driveway, or maybe they have a driveway that's taken from them, we want to be able to justify it using empirical safety data. And so we developed regression equations for the fatal plus the injury. We also did the same thing for the total ramps for these X-ramp configurations, so that we would have a procedure that could be used to have consistency across our system when we're making this decision in the state of Texas. We also took a look at the total, pardon me, the total crashes for, the fatal plus injury and the total crashes for the Diamond interchange ramps. And there were only two critical variables that showed up on the frontage road evaluation. One is the number of driveways in the Gore region, which is something we saw with the other one. The other is the prevailing number of lanes between Gore 1 and Gore 2, also something we saw with the other one. So they have two common variables, and then of course I just noted this. This is the one that would be influenced by the intersection location, so we excluded those within 250 feet of the intersection. We developed equations for them too. I'm not going to go through the equation, but what I thought might be used is just to kind of show you one example calculation of testing it to see if you compared one versus the other, similar prevailing conditions, knowing that when we took the traditional Diamond interchange and converted it to the X-ramp, we knew we were taking weaving vehicles and moving them off of the freeway and onto the frontage road. So if we know we're taking weaving vehicles and moving them off of the freeway and onto the frontage road, our expectation for number of crashes would be that probably the crashes are going to go up on the frontage road. And hopefully they're going to go down on the freeway, which is the phase 2 section. So looking at that, if we want to just do some and compare them side by side, this one is just basically a typical driveway. It had 5 driveways in the Gore region. The ratio from the Gore length to the total length of the segment was about 400, it was 0.3. And then we took a look at the distance to the upstream and the downstream. Took a look at the number of lanes between the Gores. Remember, that was a critical variable for both. And when we do that, we find that the predicted number of crashes is about 6, or 2 per year. And the predicted number of total crashes was 24, so about 8 per year. I would be amazed if we have only 8 per year crashes on some of our frontage roads. So that was actually not bad news for total crashes. I would prefer to see fewer fatal and injury crashes, of course, but this is, of course, always a problem on these facilities. So if we take a look at the same example calculation, there's only 2 of those variables that are really critical for the Diamond, which is, again, the number of driveways and the number of lanes. Those are the 2 I have highlighted in red. And when we did the equations for them, we found out that the fatal plus injury had about 4, which is really just over 1.3 per year. And the total had 19, which was 6.3 per year. So if you wanted to look at that side by side, what we saw was that for the X-ramps, for the same set of boundaries, for the same facility type, same characteristics and traffic volume, same Gore ratio, what we saw was that you would have about 2 predicted crashes per year for X-ramp configuration. And that one was 2.0. I didn't round it up or down. It just happened to come out conveniently at a nice whole number. And about 8 for total crashes. When we look at the traditional ramps, it's 1.3. And if you rounded it, we usually round crash data up. It would actually round up to 2. The other is 6.3, so if you round crash data up, it would round up to 7. So we're really comparing 2 to 2 and 8 to 7, which means that we haven't really shifted. With this one simple example, we've done several of these to try and see if this holds true. We haven't really shifted that many crashes off of the freeway and onto the frontage road. We've just shifted the operation so that it's functioning better onto the frontage road with our configuration modifications. So some additional thoughts, observations. It's clear that the number of Gores in the region, driveways in the Gore region are important no matter what the configuration is, ramp or Diamond ramp or X configuration. That seems to be one of the most influential factors, the Gore region itself. The X-ramp configuration, if you have the same characteristics, will be just a slightly higher number of frontage road crashes than for the Diamond. The number of frontage road lanes is almost always influential when predicting the frontage road segment crashes, particularly between the 2 Gores. And just a reminder, phase 2 is currently underway, and there we're doing the same evaluation. We're just now taking a look at freeway crashes at these exact same locations. We're adding in 30 more sites through Diamond interchanges as well to try and balance that out. So that's the phase 2 activities, as we're doing that assessment. When it's finished, we've been asked to provide them a self-calculating spreadsheet so they could use that in their different district offices so that when they have driveway requests or when they do a modification and actually request that a driveway be relocated, they'll have some substantial justification to support their request. And then in the event that someone doesn't, have their laptop ready, it would be handy just to have a few little charts that they could just pull out and pull the chart and look at this figure and say, yes, this is the number we'd expect. And so we told them we would look and see if we could assemble some charts to demonstrate site characteristics as well. So that's kind of in a nutshell the project that we've been working on. It's kind of an interesting, new, fresh look at how you do X configuration and some of the effects that it has, particularly on access management. I'd be happy to take any questions if you have any. Yes?
With the X configuration, aren't you just moving your weave on the freeway from being between the bridges to being over the top of the bridge? Am I interpreting that correctly?
So his question is, with the X configuration, aren't you basically just moving the weave from being between the bridges to over the bridge? Effectively, that's what you're doing, yes. But it does have the ability to then restrict back up from the frontage road, which the other configuration didn't stop. Yep. Any other questions? Gil?
Have any of the ramp terminals coming from the freeway to the frontage road been signalized?
No. No, that was an exclusion. We didn't use any ramp metering at all. You're talking about for them to be off-ramp signalized?
The off-ramp being signalized. Or well, just in general, I assume that you're telling me you didn't do that, but...
No, yeah, there are no
ramp
ramp signals. Yeah. If there was, there were some on-ramp traffic signals at some of the sites, and we excluded those on purpose because we wanted to compare apples to apples. Yeah. Any other? Yes.
What was the, I mean, there's a cost to flip these ramps.
An expensive cost.
Yeah, what was it about per interchange?
To tell you the truth, I don't recall the specific numbers for the typical ones. We did actually flip some in College Station. In fact, we flipped almost all of them in College Station. The last one's being finished right now. And in the College Station one, in the news media, they were saying they were in the neighborhood of $800,000. The College Station ones were not as complex as some of the others that had to have retaining wall systems put in place. So I'm suspecting in the urban environments, they were much more expensive. Don't know how expensive, but probably case by case. Well, I have been told operationally, based on operations, that it is a win-win. But safety, we will find that out pretty soon. Any other questions? All right, thank you.